Welcome again, and in this video we're going to have more details about the LED, the light emitting diode. We're going to have more details about the resistor. We are going to explore the use of jumper wires, and we are also going to explore the use of the breadboard in coming up with a simple circuit which I have just drawn. So first things first, let me put these things aside. I'll put them aside. Let us start with the LED. Placing the LED there. So the LED, this is the LED. The LED in full, as I said earlier on, it's called the light emitting diode, and that's the one we're talking about, the light emitting diode. The LEDs come in different colors. You can have a variety of colors you want, and they also come in different sizes. So the one we are working with today has 2 pins. You will note that it has a long pin and it has a short pin. So those are the pins there. The long pin, as I said earlier, the long pin will always be connected to the positive side, and the short pin will always be connected to the negative side. And the negative side, that's what we call ground. And in electronics, the short form of ground is GND. So this is the circuit we will come up with. You will notice that I have drawn a certain zigzag figure or diagram. This diagram represents the resistor, and that's the next thing we are going to talk about. So I will want to name it as a resistor. Resistor. So what is a resistor? A resistor, let us take, for example, we have water or we have a car moving. So this car moving, if we want the speed to reduce and the power of the car to reduce, we will have to hold the brakes at a certain angle. If we maintain the brakes constant at that angle, that constant angle is the value of our resistor. We are resisting the movement. So what a resistor does in a circuit, and this is a circuit, we've talked about circuits, it resists the flow of current. So I know I have brought a new term, and this new term is current. So you are wondering what current is. So current is something that flows and is what generates power from your power source. So the current is the one that always flows from the positive, and it ends up at the negative, where we call ground. And we can take current as water flowing in a pipe. So when that water is it's flowing in a pipe, and we have something restricting the movement. If a lot of water flows through this pipe, it will end up blowing. Maybe this is something like a dam. The LEDs is our dam. It will end up blowing the dam. So we have to make sure that, depending on the size of the dam, and this dam of ours, the LED, depending on its size, we have to make sure that we have a specific braking system which can allow the specific amount of water to get to this dam of ours. So that's why we will need a specific value or a specific size in terms of rating of a resistor that will be able to resist or block out some current, so that we don't end up blowing our light emitting diode. And now you've understood clearly the work of a resistor. It's just to limit the amount of current going through our light emitting diode, and hence just making sure that our light emitting diode is safe and is not blown out. So it can always be put, you can put it on either side, it doesn't harm, because in a circuit it's just total, the summation of the resistance in that circuit. So long as we have it on either side, it's like putting brakes. You can put brakes at the front tires or at the rear tires. So having the brakes at the rear tires, it will also reduce the flow rate. So even having the resistor here, it will still reduce the flow rate of the current, and also having it here, it will still reduce the flow rate. And that's why we don't have polarity for the resistor. The resistors, they just come like this. I'm the one who folded it like that. They come like this. So they typically don't have polarity. Either side, you can connect it on either side. Yeah. So I have taken you through resistors, and I've told you a resistor is just something that resists the current. It reduces the amount of current going to the light emitting diode so that we don't blow it. And we've said the light emitting diode is like now our dam. Water flow, we are just controlling the amount of water going into our dam. If that water is a lot, our dam will be spoiled. It will overlap, it will go over the dam, and our dam might break down. And we've said the G and D is always the negative side. It's the negative side. So with the negative side, we normally call it ground. Ground is just the short form of G and D. So next thing, we are now going to have this circuit of ours having this. Of course, these wires will be using jumper wires. We say these are jumper wires. We're going to do, in the next video, we're now going to do this circuit on a breadboard and see how it is physically.